Google Cloud is one of the leading cloud service providers in the IT industry. It provides a variety of cloud services such as compute, storage, databases, networking, artificial intelligence, and many more. So in today's session, we're going to talk about one of Google Cloud services, which is the networking service. But before we get started, I would like to address the agenda for today's session. Firstly, we will talk about Google Cloud Platform and then understand what exactly is Google Cloud VPC or the virtual private cloud. Moving on, we will briefly talk about other Google Cloud networking services like load balancing and Cloud DNS. Finally, we will conclude our session with the demo part where I will explain how to create a VPC. Now moving on to our first topic, what is Google Cloud Platform? Well, Google Cloud Platform is a suite of cloud computing services and management tools offered by Google. It runs on the same cloud infrastructure that Google uses internally for its end-user products such as Google Search, Gmail, Google Photos, and YouTube. GCP is one of the leading cloud service providers along with Amazon Web Service and Microsoft Azure Cloud and owns 7% of the total cloud market share. Many enterprises are increasingly adopting Google Cloud Platform because the services offered by Google are more secure and cost-effective. Gartner has positioned Google as a Magic Quadrant leader among the furthest three position vendors, along with Amazon Web Services and Microsoft Azure. GCP's global network spans across 25 regions with 76 zones and is available to the user from 200 plus countries and territories. Now let us take a look at the core services provided by GCP. First is the Google Cloud Engine, which is Google's infrastructure as a service virtual machine offering. It allows customers to use powerful virtual machines in the cloud as server resources instead of acquiring and managing server hardware. Second is the GCP Cloud Storage, which is an object storage system. It can store the entire organized databases, raw video streams, and even the matrices for machine learning models. Its record maintains both the identity and the structure of any class of data given to it. Third service is networking. GCP provides tools that makes it easier for you to manage and scale your networks. It provides a single place to publish, discover, and connect all application services, reducing the management and operational complexity. We're going to talk about this service in details today. The next service domain is big data. Now, GCP provides multiple services like Dataflow, Dataproc, and Data Fusion to help you create a complete cloud-based big data infrastructure that supports big data storage and analysis. Now, the advantage of hosting big data infrastructure in the cloud is that it provides unlimited data storage and have easy options for highly parallel big data processing and analysis. Next, GCP also provides all the tools developers and the development team needs to be productive while writing, deploying, and debugging applications hosted in the Google Cloud. The next service is GCP IAM. With IAM, you can manage access control by defining who has what access for which resources. It lets the administrator authorize who can take actions on specific resources, giving you full control and visibility to manage Google Cloud resources. The next service domain is GCP IoT. Now, GCP provides with an intelligent IoT platform which is scalable, fully managed, and integrated. It lets you connect, store, and analyze data at the edge and in the cloud. Finally, we have Cloud AI. GCP provides fast, scalable, and easy-to-use AI offerings, including an artificial intelligence platform, video and image analysis, speech recognition, and multi-language processing. Now, these were the few core service domains of GCP. Now, let us move on to our next topic and see what is Google Cloud's virtual private cloud. Google Cloud Virtual Private Cloud provides network functionalities to compute engine virtual machine instances such as Google Kubernetes Engine containers, App Engine Flexible Environment, and other Google Cloud products which are built on Compute Engine virtual machines. Basically, VPC provides networking for your cluster-based services that is global, scalable, and flexible. Now, Google VPC is quite different from the VPC of other cloud service providers. Now, in the traditional VPC or the VPC provided by other cloud service providers like AWS, the architecture would look something like this. Now, here in the first diagram, we can see that there is two VPC built with two different subnets in two different regions, which are US East and US West. Now, the virtual machine in one region can access the internet and communicate with the other virtual machine only through the VPC gateway, which acts as an interface. In the traditional VPC, one virtual machine cannot directly communicate with the other virtual machine. Now, in the Google version of the virtual private cloud, it is a global construct, which means instead of creating a VPC in US West and the other one in US East region, you just create one VPC and put the subnet in different region within that VPC. Now in this case, the virtual machine present in one region can directly communicate with the virtual machine in the other region, without the help of the VPN gateway. Now the communication between the virtual machines is handled by Google underlying network. This is the same network that Google uses for its search engine, YouTube, Gmail, and its other applications. Now the Google version of VPC can be very helpful. Let's say for a large project, you use the traditional approach. Then you have to build multiple VPC and multiple gateways, which will be very hard to maintain and to keep a track of. Now with Google VPC, you just have to create one VPC and a gateway and can create multiple virtual machines in multiple subnets. It is much simpler and easy to maintain. Also, if something goes wrong with the traditional network infrastructure, it would take a lot more time and cost to identify and resolve the issue. In Google VPC, there are fewer network constructs to break and troubleshoot. This would help in identifying the problem faster and solving it. Now let us understand VPC networks. You can think of VPC network the same way as a physical network, except that is virtualized within the Google Cloud. A VPC network is a global resource that consists of a list of regional virtual subnetworks in data centers, which are called as subnets. And all these are connected by a global wide area network. Also, VPC networks are logically isolated from each other in the Google Cloud. Now, some of the functionalities offered by Google Cloud VPC networks are: it provides connectivity for your compute engine virtual machine instances, including Google Kubernetes Engine clusters, App Engine instances, and other Google Cloud products built on compute engine virtual machines. It offers built-in internal TCP UDP load balancing and proxy system for internal HTTPS load balancing. It can also help in connecting to on-premises network using Cloud VPN tunnels and Cloud Interconnect attachments. It distributes traffic from Google Cloud External Load Balancer to the backend. Now to understand VPC network better, let us take a look at its architecture. Now here you can see we have two regions, US West 1 and US East 1 in a VPC network. Now a region is nothing but a specific geographical location where you can host your resources. And a region can have 3 or more zones. For example, US 1 region has 3 zones, US East 1A, US East 1B, and US East 1.3. Now talking about zones, zones are independent of each other. They have completely separate physical infrastructure, networking, and isolated control planes. This is to ensure that typical failures event only affect that zone. Now coming to subnets. A subnet or a subnetwork is a segmented piece of a larger network. The virtual machine instances can be created in the subnet, and the instances can communicate with each other in the same VPC network using the private IP addresses. Here you can see there are 2 virtual machines in US East subnet and there are 2 virtual machines in US West subnet. Now these virtual machines can access the internet through the VPC routing. VPC routing decides how to send traffic from the virtual machine instances to the destination. The destination could be either the other virtual machine instances or the internet. Moving on, let us understand a few important concepts in VPC like IP addresses, routes, and firewall rules. You will find all these concepts in Google Cloud VPC's console. So first, let us talk about IP addresses. Now each virtual machine instances in GCP will have an internal IP address and typically an external IP address. The internal IP address is used to communicate between instances in the same VPC network, while the external IP address is used to communicate with instances in other networks or the internet. These IP addresses are ephemeral by default but can be statically assigned. Now ephemeral means the IP address will keep changing every time the virtual machine restarts. Now talking about the VPC routes. Route tells virtual machine instances and the VPC network how to send traffic from an instance to the destination. The destination can be either inside the network or outside of Google Cloud, which is the internet. You can also create custom static routes to direct some packets to specific destination. Now each VPC network comes with some system generated routes. There are 2 different system generated routes. First is the default route. This route defines a path for the traffic to leave the VPC network. It provides general internet access to virtual machines that meets the requirement. It also provides the typical path for private Google access. Next, for communication within the network, there is subnet routes. It defines the path for sending traffic among instances within the network by using internal IP addresses. But for one instance to communicate with another, you must configure appropriate firewall rules because every network has an implied deny firewall rules for ingress traffic. Now talking about firewall rules, each VPC network implements a distributed virtual firewall that you can configure. Firewall rules allow you to control which packets can travel to which destination. It lets you allow or deny connection to or from your virtual machine instances based on configuration that you specify. Now when you're creating a VPC firewall rule, You must specify the VPC network and a set of configuration that defines what the rule does. The configuration enables you to target certain types of traffic based on the traffic protocol, destination ports, sources, and destination. You can create and modify VPC firewall rules by using a Google Cloud Console, G-Cloud command line tool, and REST APIs. Now, these were some of the important topics in Google Cloud VPC. Now, let us move on to the next topic and see some of the benefits of Google Cloud VPC. First is, it is global. Using a VPC gives you managed global networking functionality for all your Google Cloud resources through subnetworks known as subnets, which are hosted on Google Cloud data centers. A single Google Cloud VPC and its subnets can span across multiple regions without ever connecting to the public internet. It remains isolated from the outside world and is not associated with any specific region or zone. Second benefit is, it is shareable. Now, an entire organization can use one VPC and share it across the various teams. Different teams can be isolated within projects with different billing and quotas, yet they can still maintain a shared private IP space and access to commonly used services. The next advantage is, it is expandable. Google Cloud VPC lets you increase the IP space of any subnet without any workload shutdown or downtime. This gives you flexibility and growth option to meet your needs. Now I guess you have some idea about VPC. Now let us move on to the next topic and see what is Google Cloud Load Balancer. Basically, a load balancer distributes user traffic across multiple instances of your application. By spreading the load, load balancing reduces the risk that your application experience performance issues. Google Cloud offers 6 types of load balancer, which are external HTTPS load balancing, SSL and TCP proxy load balancing, external TCP UDP network load balancing, internal HTTPS load balancing, and internal TCP UDP network load balancing. Now, to decide which load balancer best suits your implementation, consider factors such as global and regional load balancing. You can use global load balancing when your backends are distributed across multiple regions. Your user needs access to the same application and content, and you want to provide access by using a single IP address. You can use regional load balancing when your backends are only in one region. The next factor is external and internal load balancing. Now, external load balancer distributes traffic coming from the internet to your Google Cloud VPC network. An internal load balancer distributes traffic to instances within the GCP network. And the last factor you need to keep in mind is the type of traffic that you need a load balancer to handle, such as HTTPS, TCP, or UDP traffic. Now, this was a brief information about Google Cloud load balancing. Let us move on to the next topic and understand what is Cloud DNS service. Google Cloud provides a scalable, reliable, and managed domain name service or DNS running on the same infrastructure as that of Google. But before we get into Cloud DNS, let us understand what DNS is. So DNS is a hierarchically distributed database that lets you store IP addresses and other data and look them up by names. In other words, DNS is a directory of easily readable domain name that translate to numerical IP addresses which are used by computers to communicate with each other. For example, when you type URL into a browser, DNS converts the URL into an IP address of a web server associated with that name. Like www.example.com is translated to IP address of 72.220.193.173. Then the DNS directories are stored and distributed around the world on domain name servers that are updated regularly. Now, Cloud DNS is a high-performance, resilient global DNS service that publishes your domain name to the global DNS in a cost-effective way. Cloud DNS lets you publish your zones and records in DNS without the burden of managing your own DNS servers and software. Cloud DNS offers both public zones and private managed DNS zones. Now, a public zone is visible to the public internet, while a private zone is visible only from one or more virtual private cloud networks that you specify. This was about Cloud DNS. Now let us move on to a demo part where I will show you how to create a VPC network in Google Cloud. So for our demo, I've logged in into a GCP account. For people who are new to GCP, this is what the GCP console would look like. Now it is very simple to create a GCP account. All you have to do is enter your debit card or your credit card details and your address. Then you might be charged maybe a rupee, but even that would be refunded later. And after you sign into a new account, GCP will provide you $300 free credits. You can use this amount to explore Google Cloud services. You won't be charged until you choose to upgrade, and it will be valid for 90 days. Now coming back to a GCP console, you can see we have the project info over here. Now you must have a project in order to use the GCP resources. And here will be the list of resources that your projects use. Here will be the billing, the monitoring dashboards, If you're new to GCP, you can explore the various services provided by Google Cloud. So demo is going to be very basic, where I will explain how to create a VPC and subnets. So the first step is to select a project. Now if you're using GCP for the first time, you can just create a new project from here. Click on New Project, name your project anything you like, and just create it. Now for this demo, I'll just select from an existing project. So I'll let this be, and now let us search for VPC over here. And we'll select the VPC network. Now you can see here that Google Cloud comes with a default VPC. And this VPC has 25 subnets, each subnet having its own IP address and in a different region. As I mentioned before, GCP has 25 regions and 76 zones. So each subnet is created in 25 different zones. Next, you see something called mode over here. And you can see there are two types of mode, custom and auto. We will talk about this when we're creating a VPC. And there are 4 default firewall rules. So let us now create a new VPC. So I'll just go to create VPC network. And we can name our VPC anything we want. So I'll just name it demo VPC. And you can see only lowercase letters, numbers, and hyphens are allowed. Next, you can describe your VPC, but this is optional, so I'll just skip it. Now coming to subnets, we can create a subnet with 2 different methods. One is custom and the other one is automatic. If you select automatics, subnets are automatically created with different IPs in different regions. Now you can see in automatic, 15 subnets are created in 15 different regions. If you want, you can select any firewall rules from here. Now as I mentioned before, firewall rules allow you to control what packets can travel to which destination. Now with the demo VPC allow ICMP, it will allow only ICMP traffic from any source to any instances in a network. And with the allow internal firewall rules, it will allow connection for all protocols and ports among instances in the network. Next, the allow RDP firewall rules allows RDP connection from any source to any instances on the network using port 3389. The port is given over here. Next is the allow SSH traffic rule. This allows TCP connection from any source to any instances in the network with the destination port 22. Next, these two are the default firewall rules. And the default routing mode is set to regional. You see, Google Cloud makes it very simple for you to create a VPC. All you have to do is just name your VPC, select automatic and click on create button, and then your VPC will be created. But for this demo, we're going to select the custom subnet and create only a few subnets. So we'll just go to custom. Now we can name a subnet anything we want. We'll just name it demo VPC subnet. If you want, you can add description about your subnet. Next, we have to select a region. So these are the available regions. So we'll just select US East 1 and we have to mention the IP address range. So we'll just mention 10.0.1.0.24. Next, we have something called the private Google access. This means I can set my virtual machines in the subnet to access Google services without assigning an external IP address. So I'll just on this. So now my virtual machines will be able to access Google services without an external IP address. I will let the flow logs be off. Flow logs are just to record the network flow. If you want, you can on it as well. I'm just going to click on done. Next, we can select regional or global routing mode. Regional routing will route only in the region they were created, and global routing will route to and from all the regions. So let it be default regional. Now let us create another subnet. We'll just name it demo VPC subnet 2. And the region will select US West 1. We'll give the IP range as 10.0.2.0/24. We'll let the private Google access be on and click on done. Now I'll just create my VPC. Now VPC is being created. This might take a couple of minutes. Now you can see a VPC is successfully created. And 2 subnets are created in US West 1 and the other one in US East 1. So that's all for today's session. With this, we have come to the end of our video. I hope this video was helpful. Happy learning.